Okay, here's our next applications example. So here it says, an enterprising group of students grow maggots for a fly trap to sell as live bait for fishing. Yum. Rather than counting the maggots, they periodically weigh the contents of the trap. The students believe that a good model for the growth of the maggots would be that the weight W of the maggots would increase at a rate proportional to the weight itself at any given time. So initially we have our initial conditions here, telling us what it is at 300, and then 4 days later it's 500 grams. So question 1 is asking us to describe this process by writing a differential equation. And so it says the maggots increase at a rate proportional to the weight itself at any given time. So change in weight with respect to change in time is proportional to the weight itself, which means that change in weight with respect to change in time is equal to some constant times weight. So this is something that you'll probably get used to with these types of questions. If it's a proportional relationship, then it's the same as that variable being times by some constant. So if we're going to come up with a differential equation, we need to split it into its what we're going to integrate with respect to. And so at the moment here you can see that I've got w's with t's, so that doesn't work. So I'm going to have it as 1 over w with respect to w and k with respect to t, and then we're ready to integrate both sides. So we get natural log of w is equal to kt plus c. And so if I'm wanting it in terms of w, then I'm going to have to take the power of e of both sides. So w will be equal to e to the kt plus c, which we can write as e to the kt times e to the c. And e to the c, we usually just write that as a. And so we can write this differential equation as a e to the kt. So I've actually got two constants here that are going to be of different values that we have to solve for. And that's why we have two different conditions. We have initial conditions and conditions 4 days later, because we've got two things to solve for. So when weight is 300, our time is equal to 0, and so because k times 0 is 0 and e to the 0 is 1, that means that our value for a is simply 300. And you'll get used to the fact that you can skip straight to this step because initial conditions give you that a value straight away. Then we're told 4 days later it's 500, so we've got a weight of 500 when t is 4, and so we can solve this equation for 500. So dividing both sides by 3, sorry for t, dividing both sides by 300, we've got e to the 4t equals 5 over 3, and so 4t is equal to log of 5 over 3. And so t is equal to natural log of 5 over 3 divided by 4. So we need a calculator for that. So natural log of 5 over 3 divided by 4. So 0.128. So, sorry, that shouldn't be t, that should be k that we're solving for there. So k, k, and k. So k is equal to 0.12, what did we say? 8. Alright, now even though we're using this abbreviated version, we'll continue to use the exact version in our calculator. So all in all, we'll bring it over here. Our equation is going to be w equals 300 e to the 0.128 t, and that's our differential equation, and so that's our answer for question A. So for question, actually, this was our question, this is our answer for question A, so we've actually answered question B already, sorry, which is solve the equation, so question B. Okay, question C is asking us to find the weight for maggots after 10 days, and so that's simply putting in 10 for t, so we've got 300 e times to the power of 1.28 times 10. So we'll bring up our calculator, we'll put that into memory, so we'll have 300 e to the, put it in a, times 10. So we get 1076 to the nearest gram. So weight equals 1076 grams after 10 days. When does the model predict the weight to be 2 kilograms? So for this one, we're setting our weight at 2 kilograms. So we're going to go 2,000 for our weight because we're working in grams, equals 300 e to the 0.128t. So dividing both sides by 300, e to the 0.128t equals 20 over 3. And taking natural log of both sides, 0.128t equals natural log of 20 over 3. And so t is going to equal natural log of 20 over 3 divided by 0.128. Okay, so let's put this information into our calculator. So we're going to have natural log of 20 divided by 3, and we're dividing that by that number we've saved in our memory. So that's 14.85. So t equals 14.85. And t is measured in days, so if we go into the nearest day, we'll just say after 15 days, the weight will be bigger than 2 kg. And that's it. So, yeah, that's how we can apply differential equations to certain situations. You've got to be quite flexible with how you apply them. And sometimes you'll be given a model and sometimes you have to come up with a model. But just remember what happens there with the constants a and k when you've got something like that. So have a go at these ones in exercise 23.07, please.